All right. Well, we are recording now. I just realized that we weren't recording previously, but we are now. So hopefully things went well in week one. The only things I wanted to bring up were don't miss out on more extra credit. Okay. So we have roughly 65 people, I think, between our two sections, and only a handful posted on the spiritual discussion in iLearn. That's just on the announcement. If you just go to the announcements tab, just once a week, there's not like an assignment in iLearn or a due date or anything like that. But Nicholas adds extra credit onto an assignment each week, usually on Monday. And so you usually have a full week to post on that discussion to get extra credit for it. Questions about chapter 1 content, computer hardware? Did you guys have any questions that you wanted to talk about today? Okay, I felt like it was pretty straightforward, the chapter in and of itself, but a lot of questions were brought up last week, so hopefully they all got answered. Week 2 deliverables. So you have your chapter 2 review questions due Tuesday night. Robbie the robot. Now all these days, I think they're right, but if they're not, just ignore this and pay attention to iLearn and what's on the calendar in iLearn. But you have your peer review. Again, that's just right in Slack. So if I open up Slack here, we have our week 1 discussion, which is where everyone posted their introductions. And then our week 2 peer review, that's where our peer review will take place. Okay, people started posting last week, but yeah, so this is where you will post. Go ahead and run this code as well. So if you have Robbie the robot opened up, go ahead and just copy and paste this code into there so you can see what it's doing. So let's see what else. And then peer review journal and self-assessment survey.
The reminder that we got, so it's like the week 2 reminder for peer review. Do we just mark that off?
Yeah.
It's like a reminder? Or...
Yeah, it's not due at all. One thing that I like to do, let me close this. Let's see here. So in the syllabus, and you can do the same thing if you just go to grades too. And I just kind of realized this because I'm taking some classes as a student right now. And one of the classes that I'm taking, there's like a crazy amount of stuff in iLearn. And I'm like, I don't really care about all this stuff because I'm not graded on it. So anyways, if you kind of have that mentality or you're feeling good about the course, this is a really good place to go to kind of see like what's being graded. And then you can just like click on these. And so that's here in the syllabus, but then also your calendar. I guess your calendar will have everything, even if it's not graded. But yeah, so, or you can just click on the grades section in iLearn to see that stuff. All right, any more questions before we go into chapter 2?
One comment, Brother Bridge.
Yeah.
I think we said final submissions are Saturday nights.
Okay.
So just heads up. So it's like Saturday night is when, Tuesday night you take your quiz. By Thursday you should comment on at least 1 or 2 peers codes. And then by Saturday you take your final quiz for the week, which is self-assessment, and you submit your code.
Awesome. Awesome. Thanks, Nicholas. I wanted to show you guys one thing real quick. Not a JavaScript video. Hopefully it'll be pretty easy to find. So if you click on week 2, Robbie the robot, and then we'll go into the chapter, I promise. But it probably won't take too long. So if we click on Robbie the robot, it has this external tool that you do everything in. What is here? Okay. Let's see here. I wonder. So we talked a little bit about the developer tools, right? And so I wanted to show you guys something that you can do with those. But first, let's say I just copied somebody's code in here. I could just come in here and I could run it, hit run, and I can see exactly what it looks like and what it does. Now, F12 is a nice hotkey for opening up your developer tools. If you don't have F keys or don't want to work with your function button on your laptop or anything like that, you can right click, hit inspect. Looks like Control-Shift-L will also do it for you. But these developer tools, so the elements actually show what is on the page. And so I can like click on this arrow and I can click on something in here and it will show, you know, oh, this is a div, you know, and we'll learn more about this HTML next week. Console, and then we have sources, okay? Let's see, where is it? Tool content. It might not be in here anymore. I'll have to look for it and find it. So this is JavaScript that's running in here, and then it's executing JavaScript that comes in that you type in. But there, I should have looked for this beforehand. But you can actually like look at the code to see what this Robbie the Robot code is actually doing, to see how it works. And the reason why I thought of it was because this is really, really, really long, and you can change the speed at which the robot moves. So I'll see if I can find it, and then I'll share it with you guys. But, okay, well, sweet. Well, I hope you guys have fun with this. It's kind of fun. So, okay, so week 2 deliverables we talked about, and then our chapter we're talking about algorithms and computer programs. So again, we have computer hardware in week 1, algorithms and computer programs in week 2, to kind of start thinking about how you will write programs. Okay, a lot of people when they start writing programs, it's a big change from just thinking through things the way that you regularly do and starting to think through things programmatically. And so that's why we focus on this in week 2. And then week 3, we go into HTML, and then week 4 through the rest of the semester will be pretty much all in JavaScript. So algorithms, a list of steps to perform a simple task or to perform a task. One does not simply write an algorithm, okay? Instead, you write a defining table, okay? A defining table is a useful tool to help you understand a problem. It helps you conceptualize the input, output, and processing. In fact, that's all it is, okay? A defining table will just have the input of a program and then any processing that takes place and then output, okay? The reason why it's organized right here as input, output, processing is because a lot of the time it's easier to think about the input or output first, and then the input or output second, and then what kind of processing has to take place to connect those two things. So as an example, let's say you work for a large construction company. Your boss has asked you to write a computer program that will read a list of window openings for a building and then compute and output the total cost of all the windows. The window openings are entered in inches with the width first and the height second. The cost of a window is computed by multiplying the area of the window in square feet by $35. So if we started with the input, what would I put in this input box here of my defining table? What will our input be?
How many window openings?
Yeah. So right here, we'll read a list of window openings. So yeah, exactly. And then that'll also go along with dimensions. You know, when a user inputs the window openings, it'll have the width and the height for each one. Good. What will the output be?
Cost?
Yep.
Total cost.
Exactly, yeah, because right here it says the output and output the total cost of all the windows, okay? And then what would our processing look like? We know our input, we know our output. How do we get from our input to our output?
It would multiply the area of the windows by $35.
Exactly, yeah. So each window, we'd have to take each window and get the dimensions of each, and then the cost of each, multiplying it by $35, and then just adding the cost of each window, okay? And that would give us our output. Awesome, you guys. Okay, so if I was gonna write all that down, a list of window openings, and then for each window we have width and height, total cost of our windows for our output, and then for each window, area times 35, and then add that cost to the total for all the windows. Okay, let's look at our next one. You have been asked to write a program that will read from the keyboard the radius of a circle and will output to the monitor the diameter, circumference, and area of the circle. Okay, if we're gonna look at that, our input, we just have the radius, our output, diameter, circumference, and area, exactly what we just read. And then for each one of those, we'd have to do a little bit of math, okay? So to compute the diameter, we just say radius times 2. Compute the circumference, we say pi r squared. And to compute the, 2 times pi times r, sorry about that, that's the circumference. And then the area is pi r squared. So, okay, any questions on this example? Okay, let me show you guys real quick. So for our class, what that will look like, all right? So we will have defining tables for the majority of your code. And if I looked at, say, this assignment in week 3, okay? Let's actually look at that real quick. I'm gonna open up our course. Leave, sorry, Robbie. Because you're not actually gonna have to like make a table that looks like a table. It's just gonna basically be you writing down what the input, output, and process it, and the processing, what all those are. So I'm gonna click on this chapter 4, JavaScript Basics. And then I'm gonna go to the very bottom. You'll notice that at the very end of each one of these chapters in iLearn, it has a bunch of exercises, okay? Weeks 1 and 2 don't, but weeks 4 on, they have these different programming assignments, okay? Now yours, it looks like you have, your assignments are for exercise 1 and 2, and then 3 and 4 are just here to kind of help, you know, if you want to practice or whatever. But right here it says create and validate a well-formed HTML5 document that you can use as a template for future assignments. At a minimum, your template must contain all the tags that are required in an HTML5 document as explained in this section. It's just up here in this chapter, or of chapter 3. In addition, your template must contain opening script tag, closing tag. And so this is like the assignment for that, okay? Well, each one of my defining tables, I'll go in here and I'll say the input, I would say none, because this is a template. The processing, probably also none, because this actually isn't doing anything, okay? And then the output, also none. But a lot of our other assignments, like we get into chapter 5, and if I look at one of these, it says write a defining table in a JavaScript program to compute and output the volume of a tin can. This kind of brings me back to like elementary school, you know, when you like have a book and it's like, okay, now we have to compute the volume of a cylinder, you know, and we have to think about, okay, well, to do that, what dimensions do we need? We need the height and the radius of the can or of the cylinder. The output will be that volume, and then the processing, you know, what all goes into that? Well, we have pi times r squared times the height, okay? And so that's all these defining tables are. A lot of time people get hung up on this, like, what's the defining table? And all it is just input, processing, and output. It's to help you kind of conceptualize, you know, what does your program need to work? What is the goal of the program? And then how do you get to that goal with what you have? And so if I look at this, you can see this whole thing is an HTML document, all right? And I know that in part because it says HTML here, but also all these funky tags with like the lesser than, greater than signs, these are HTML tags, okay? And you'll notice that this looks strikingly different than this, okay? This right here is JavaScript, and it's very functional, okay? And all these tags look a little bit more procedural in my mind, but these will basically just put something onto a page for you to view. And so if I look down here, I can see I'll have like a header, and I'll have a couple of input boxes and labels for the input boxes, breaks, a button, and then a div or a divider, just a place to have my output, okay? Well, this button will go in and call my calculate volume function in my JavaScript, and then it's gonna say, okay, let's find the ID height in the HTML. It's like, oh, here's this input with an ID called height. And then we'll take that value and we'll assign it to a variable called height. And then we'll take the input called, or the ID called radius, we'll take that value and we'll assign it to a variable called radius. Then I do my math, and then I can output that volume to my output div. Okay, and so this right now, obviously you're not gonna have to worry about most of this for about 2 weeks. Next week will be HTML, and then in 2 weeks, you know, we'll start having JavaScript being called from HTML when you click a button or something like that. But what I'm wanting to point out here to you, to kind of give you a where are we going perspective, is this defining table right here. How helpful this defining table can be as you write your programs. Because a lot of the time, people will see this and they're like, oh, well, yeah, duh, of course, that totally makes sense. But we're covering this right now, so you can start thinking very programmatically. Be like, okay, I need the circumference of a circle. How do I do it? Well, I can't do it without a radius. Okay, so once I have the radius, how do I get the circumference? Well, I would just Google, because I haven't worried about circumferences in years, So anyways, this is here just to kind of give you that perspective and how to break up a problem by input, processing, and output. So that when you get into code, you can be like, okay, I have my input. What do I have to do for that input? Okay, well, I'm going to need input boxes, and then I'm going to have to use these functions to get the inputs. All right, so if I had to split this up by each part of this, I'd say this is the input, this is the processing, and this is the output. Okay, and so for every single one of my applications, I can kind of break up that logic. It's like, okay, I have an output of a volume. Okay, well, how do I get that? I need my inputs, and then once I have my inputs, what kind of math do I have to do to get to my output? So, all right, any questions on this or on the code that I just shared?
Just a quick one. So I know what we're supposed to do, obviously from my knowledge, is that we'll have an HTML file and then a JavaScript file on the side, and that will link them. But for this class, are we mostly just putting it all in one file so we can just send it off easier?
Yep.
Okay.
Yeah, so for anyone who doesn't know, so right here, if I zoom out a little bit, it's not letting me zoom out. There we go. So if I zoom out a little bit, again, all these tags that are all indented and stuff, this is HTML, okay? But everything inside of this script tag is JavaScript. So if I tried to put something in here that was H1, this is my big header for HTML. If I tried to run this, it would not work, okay? Because JavaScript is gonna read this and get to this and be like, that is not JavaScript, and it's gonna give me a big error. And I can look at this, if I just copy this path and go to my browser and hit F12 to look at my developer tools, you see this red X right there? If I click on my console, I can see it, and it says unexpected token, this lesser than sign, and it says line, is that 1 or 5? But it shows exactly where it is, where that error is. And because of this, if I tried to get the volume of the can, nothing will happen. Notice that this says 2 now, so I can come back and it says reference error, calculate volume isn't defined. And it's because there's a JavaScript error, and as soon as it came across this error, it didn't read anything else in my JavaScript. It's like, nope, this stuff's broken, fix this first before I'll do anything else, okay? And so if I have these errors, I won't be able to do anything. So back to this, I have my HTML document, and then in this script tag, it's not gonna look for HTML, it's gonna look for JavaScript. So I can't put HTML in here, it has to be JavaScript. Likewise, here's something interesting. This right here is a JavaScript comment. All right, now in VS Code, I can see this really easily because it's this nice green color. And so these things that I put in here, notice it's that same green. These are single line comments. And all a comment is something that won't actually get executed by the JavaScript compiler. So what reads the JavaScript code, it's gonna skip over the comments. The comments are just for us, which is really nice. So I can put this defining table in here as a comment, and then I can put little single line comments in here if I want to, for input, processing, and output. But if I put this, if I just copy this and I put it down here in the body of my document, notice 2 things. One, it's not green, it's white, okay? And then if I come over here and I hit refresh, there's my comment, okay? So it does get rendered because HTML and JavaScript are 2 different languages, okay? Even though I can put JavaScript inside the script tag of an HTML document. Now, what Samuel was asking was, are we going to be using separate files for this? And I said, no. What we could use, instead of just having an open script tag and then a closing script tag and all my JavaScript in between, I could have something that says script and then a link on my computer to a JavaScript file. And that's what we're not going to do. If you wanted to, technically you could, but instead all of our assignments this semester, there's all going to be in HTML documents, and we'll have the JavaScript kind of embedded in here. Okay. If you were curious, this style tag right here, this is called CSS. Okay, the style tag obviously is HTML, but everything inside this style tag is CSS, which is short for Cascade Style Sheets. And it basically says how your document is going to look. So if all of a sudden I in here said background color is going to be pink, and I save it and I come back here and I refresh, my color now is pink. Okay, so our CSS kind of controls the appearance of the HTML elements. The HTML shows what's on the page, and the JavaScript makes it so that our program can actually do something. Okay, if I didn't have any JavaScript here, I could still have this input and this button, but it wouldn't do anything. Okay, I could hit this button all day and it would never do anything. Like this popping up right there, that wouldn't happen if it weren't for JavaScript. Okay, that NaN popped up because I said, hey, find my output div and show the volume there. Now that didn't work because I didn't put any numbers in here. If I put in numbers in here, okay, JavaScript just took those numbers, did all the math here that I wanted it to do, and then outputted a volume to the page. So a lot of people will look at all this and they're like, man, this is so confusing. There's like HTML and CSS and JavaScript in here. How many more languages are we going to have? And you can't have more. It's crazy. Okay, you'll have like a PHP document that has like all of this stuff in it all at once, you know, or a Node document, or, you know, and they'll all kind of be mixed together. But they all do different things, you know. With CSS, it would not be prudent of me to put an input in the page, even though technically I might be able to. It would be horribly well written, horribly written. But with just HTML, I couldn't change the color. I couldn't center volume over the can right here. That's centered on the page because of this guy right here. Okay, if I took out this pink and I commented out this text align center and I hit F5, everything is left aligned now by default. This spacing over here looks like about an inch to me is because I said margin left 10% and the entire width is only going to be 80%, which will leave kind of a margin on 10% of both sides. So if I commented that out and hit refresh, notice all of a sudden I'm going from end to end. It's taking up 100% of the view here, and there's no space on the ends. Well, because I wanted it to look a little bit nicer, I said, okay, I want a width of 80%, margin left 10%, which will make it look centered, and then I'm going to actually align my text centered as well, which will make it look like this. Okay, so we have these three languages working together. We have HTML that can actually put stuff on the page for you to see, CSS that determines how that stuff will look on the page, and then JavaScript, which makes this functional. Okay, without JavaScript, I could put stuff in here, but it would never do anything. With JavaScript, I can put stuff in here and then do math with it, or other things, a lot of other things. So, all right, any questions on this? Sweet. All right, back to here. All right, an algorithm is a list of steps to perform a task. So think of this algorithm. I preheat the oven to 350 degrees, cream together butter, sugar, brown sugar until smooth. Beating the eggs one at a time, stir in vanilla, dissolve baking soda in hot water, add to batter along with salt. Stir in flour, chocolate chips, and nuts. We could leave out the nuts, just for the record. Drop by large spoonfuls onto ungreased pans. Bake for about 10 minutes in the preheated oven or until edges are nicely browned. Okay, doesn't that just like make you want a cookie? Okay, this is an algorithm. I could think of any recipe I've ever seen as an algorithm. It is a list of steps to perform a task. Okay, I'm not going to see a recipe that just has, you know, oh, throw together all these ingredients. But even that would be an algorithm, would be a terrible algorithm. But this is an algorithm, a simple algorithm to just make some cookies. All right. And if you can think about your programs that you write in a programming class, if you can break it up into steps, then you'll be able to make amazing things. If you think about our application just now to get the volume of a can, I could break that up into an algorithm. I could say maybe display HTML on the page, and then prompt user for radius of can, prompt user for height of can, multiply the radius by whatever I need to get the volume, display that volume back on the page to the user. I can think about these things in steps so that instead of just looking at a problem for a program, I'm like, man, I have no idea how I'm going to do that. I just kind of take one bite of it at a time. So, okay, any questions on this example here? Okay. Okay, so go ahead and look at this for a minute and tell me what's missing. Okay, we don't know what this is. We don't know what it's going to do until we start reading through this. But go ahead and read through it and tell me what's missing from here.
Your fridge door is still open, but
Yeah, fridge doors open, pantry doors open, cupboard doors open. My mom would be angry. Okay, so yeah, all the doors.
You got step 9 and 10 right though. That's good.
Yeah, pour cereal in a bowl, pour milk in a bowl, start eating. Some people pour milk first, which is weird, but.
Monster.
Okay, what else is missing out of here?
Where do you get the spoon?
Oh, we get the spoon, yeah. Yeah, we're gonna be like sitting there just like eating cereal with our hands, okay? Anything else that you guys can think of?
You walked to the kitchen, but you didn't walk to anything else. So you don't particularly know if you walked to the fridge or to the pantry door or to the cupboard.
Or to the table to eat. You might just be like standing there.
Yeah, you're standing there.
Your cereal
holding your bowl.
Yeah. So notice there's a lot of stuff here. And I had never even thought, was that Christine that said that about the walking? I had never thought of that. I put the picture here of the kid eating his cereal without a spoon because that was the first thing that I thought of. But notice there's like all this stuff missing. Okay. Now, when I run a program in my browser, notice, where was that? Oh, is this it? No, this was it. Notice if I come back here, I'm going to take this defining table out of the body of my HTML document. I don't care about that there. I'm going to put this heading back here where it shouldn't be inside of the script tag. Remember, the script tag is looking for JavaScript. Say this is an HTML heading, which would be perfectly valid down here in the body. Okay, we have a heading right here that says volume of can. If I put this down there, it would just say this is an HTML heading right above this, and it would look great. But it's in the script tag. Okay. Now, if I run this, notice my program is rocking it right now. Okay. I don't really know how big this 1.19e plus 22 is, but it looks big. But my application is working right now. Now I'm going to close this and I'm going to refresh the page. Okay. My comment's gone because I took it out of here. So it's not showing up there anymore. And I can also assume that this is also being rendered now because I saved my file. All right, now I'm going to put in my radius and height again and hit enter. And nothing's happening. Okay, now this is a messed up situation because everything looks great. I'll go back here and I'll look at the code. I'm like, man, this calculate volume function, it like looks perfect. All this stuff is showing up great. This height ID exists down here. This radius ID exists down here. So why is my function working? I'm calling it on click, calculate value, calculate volume. I'm calling it from the button. It matches that. Okay, so why isn't it working? This would be very similar to just looking at this slide and not seeing a picture. Okay, maybe I should add a picture here of like a bunch of cupboard doors and fridge doors and stuff with their cupboards open, with their doors open. you know, and a picture of some poor guy like standing there in the middle of the kitchen with his bowl, like eating cereal. Okay. Like these pictures help us to visualize things that are missing. If I showed you guys this picture first, you'd be like, oh, well, there's no milk or bowl or spoon. Okay. So back to our code, just looking at this, what's being rendered is not helpful. Okay. Just looking at my code isn't helpful either because there's no error showing up in my code. But if I inspect here or hit F12 and look at my developer tools, I see this red X with a 17 there. Looks like I clicked our button 7 or 16 times. Okay, and I can actually see some errors here. This is very similar to like actually seeing a picture of a kid eating cereal without a spoon, or seeing someone standing there eating cereal without a chair to sit on, or no table, or a fridge door that was left open. Okay, these developer tools can be your best friend in this class. It should be. Okay, anytime I'm like grading assignments in this class, like people will like send me code and they're like, hey, what's wrong with this code? I can figure it out in like 2 seconds because of these developer tools, you know, because like just hitting this button, you'll never see it. You'll never see the error. It will never like pop up in the HTML of this page ever. But if you open up the developer tools, it's like, oh, there are like errors going on here. Every time I click this button, where was it? Or if I refresh this page, look at that. I didn't even like run any JavaScript and there's an error. Well, let's click on it and go over there. It doesn't like this greater or this lesser than sign. Okay. And so using these developer tools seriously will change your lives, or just make your lives awesome if you haven't done web development before. Okay. In our video spreadsheet for the class, there are, come on, little guy. These videos over here, Chrome Developer Tools 1, 2, and 3. And I kind of organized them by week of which would be the most pertinent for you at that time. So like next week is week 3, and we'll go into HTML. And that's this tab right here. Okay, I can see the head. This is my HTML, right? I can see the JavaScript, but it's not rendered in here. It just shows what is in my HTML document. All right. And I can like hover over these and see what each one is. I can click on this and be like, where's that input? It does have an idea of height, you know. And so the elements tab of the developer tools show the HTML that's being rendered on the page. Okay. And then in week 4, I'm like, you should probably be familiar with this console, because if you get errors when you start working with JavaScript, they'll show up here and they'll save you a lot of time. And then week 5, I say, yeah, go ahead and go to the sources tab now, and we'll learn how to debug this and other things as we start working on more complex JavaScript problems. So please be aware of these. Again, today I'm hoping to give you guys a good perspective of where we're going. But if you can get a good start to this right now, you know, like week 2, worrying about the algorithms, week 3, worrying about the HTML, but not leaving this video by the wayside, it will help you so much. And then week 4, learning how to use the console. And then in week 5. So just being aware of this will really help to make your lives a lot easier and a lot happier. So, all right. Questions on any of this stuff, you guys? Okay.
Just real quick, the link to that is in the syllabus, correct?
It is in the syllabus, yeah. Okay. If I open up the syllabus, it's where to get help for this course. You just scroll down, where do I get help? There's the help document, it links to it in that as well, and then the video spreadsheet.
Perfect.
And I would just recommend that you bookmark it, because it's where I have all the walkthroughs for your assignments. And it's also where I post all of our lectures and our slides, exam prep and walkthroughs, you know. So I would just recommend that you bookmark it. So yeah.
Okay.
All right, well, let's keep going. Computer programs. So last week we talked about hardware, right? And we talked a little bit about software. We talked about the BIOS, that is the first piece of software that runs as soon as power comes into the computer. We talked about the operating system that the BIOS will load for you. And then we talked about regular computer programs like applications. You know, once you have your operating system up and running, you can click on Microsoft Word, you can click on Google Chrome, you can click on Safari, whatever you have on your computer, and you can open up computer programs. All a program is a set of data and instructions. Data is stored temporarily in computer's main memory, that's your RAM, Okay, so while I'm using Google Chrome right here, all of the data for this slideshow is stored in RAM. And then more permanently on a hard drive. Okay, all these files that I have up right here with, this is just a folder on my computer, and all these files are on my computer, stored more permanently in my hard drive. Instructions are called statements and are similar to steps in an algorithm, sentences in a paragraph, parts of a recipe. Okay, and so if I look at code, you know, I can see these steps right here. And this is telling my computer what I want it to do. All right, computer operations. Computers are actually kind of dumb. They're only capable of a few basic operations. They can receive input. All right, whoops. That's what I'm doing right now with my keyboard and mouse, with my camera and microphone. I'm giving input to my computer. They can write out data. Okay, that's what speakers are for, monitors, fingerprint readers, disk drive readers, USB, you know, they can write out data. Assign a value to a variable or memory location. Okay, so if you look back at my my program right here, when I say variable height equals whatever the user typed in that input box, that's what I'm doing. I'm saving a piece of data that the user typed in into the memory of my computer. And I'm going to be able to access it by using the variable named height. Same with radius. Down here, I could use radius and height that I had declared just a moment before, and I made a new variable called volume. And then I could use that as well. Question here. Okay. All right. In addition to that, computers can perform arithmetic. Okay, the CPU in our computers are capable of performing arithmetic, and the operators consist of negation, plus, minus, addition, subtraction, multiplication, division, and modulus. Okay, our computers are capable of comparing two values. Okay, we have our relational operators: less than, greater than, less than or equal to, greater than or equal to, is equal to, and this one is not equal to. Okay, so if I wanted to, I could come over here into my code, and just for kicks, I could say, is radius less than height? Okay, well, if I wanted to print that up, that would either say just true or false. Okay, later on, you'll learn how to do that inside of like an if statement, and you can learn how to execute code based on those relational operators that you're comparing several things against. You can repeat a group of actions. Okay, if we think about our last algorithm with the kid getting the cereal bowl together, and it said repeat until there's no more cereal in the bowl. Okay, I could repeat as many actions as I wanted to out of that list of algorithms, and just say repeat, 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 repeat until that cereal's gone. Okay, I'd probably only do, you know, most of those once, you know, go into the fridge, get in the milk, get in the cereal, but maybe not. Maybe I'd have something that says, if still hungry, go and do all that again. Okay, and my computer is capable of saying, I'm going to repeat a group of actions. Call a function and return a value from that function. Okay, this example right here calls a function. Okay, the user clicks on this button that calls my calculate volume function, and then all of a sudden, this JavaScript code is running. I'm not returning anything here, but if I wanted to, I could make another function right here that says function compute volume. Okay, and maybe I have like radius and height that I'm sending to this function, and then I would just return pi times radius times height. And I use these variables here. And then right here, instead of calling, or instead of just computing volume right here, I could say, I'm going to call my compute volume function, and I'm going to pass in the radius that was just declared and height. Well, this program would now work exactly the same as it just did a second ago. Okay, my computer is able to call a function from somewhere else in code, and then return a value from that function to its call point. Okay, so right here, I did the math, pi r squared times height. I return that value to right here, and that would then get assigned to volume. Okay. Now this you're not going to do for probably like 2 months. Okay, doing multiple functions, but in a couple months you're going to be comfortable with writing multiple functions, having them work together, sending data to different functions, and then having them return values to other functions. All high-level tasks that a computer can do, such as edit photographs, play music, search data, do a Zoom class, are simply combinations of these basic operations. Okay, sometimes really, really, really complex combinations, but these 7 things are all a computer can do at its core. This is all it's capable of. Okay, but if I can repeat a group of actions and have a billion pieces of data coming in as pixels from a screen, I can just repeat and like display all those back on a screen. Okay, or I can take an audio stream and do something with it, or I can edit photographs or other images. Okay, so, but these 7 things are the only things that our computers are actually capable of doing. Control structures and the flow of execution. So by default, code will run from top to bottom. All right, if we look back at this code, before I changed this, it would have just gotten the input and then did the math, pi times r times height, and then the output. Just top to bottom, same as the way you read a book, okay? That is a control structure. That is the default control structure. Next, computer appears to make logic or make decisions. So this is if-else logic, all right? That could look like if height is greater than radius, then we'll go ahead and do something. Maybe I say alert height or something like that. All that would do is just give me a little pop-up saying what the height is. But this is logic that my computer is performing based on this relational operator, okay? And I could have a billion lines of code in here that say, okay, if height is greater than radius, then we're gonna do this, 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 and this. But this code will only get executed based on this if statement, okay? So when we look back here and it says selection is a control structure, that's just saying this messes with that default top to bottom sequence of code will always just run top to bottom. That's how it runs. But with this selection, yes, that's true until we hit here. Okay, then it will only continue to run top to bottom if height is greater than radius. If height is not greater than radius, then we'll actually skip this line of code and go down here. So it kind of messes with that default control structure. Next one, repeat or repetition. Repeat a group of statements. We can think of this as while logic. You know, so if height is greater than radius, I could actually put a loop in here that says while height is greater than radius, do something. Maybe I'll alert height, and then I could say height equals height minus 1, okay? And so if I ran this right now, what would happen is I can actually take out this if statement, but I have this while statement, and it'll check, okay? If height was 5 and radius was 2, okay, then this would be true. And come into here, we'd alert 5, we just have a pop-up that says 5, and then we'd assign height the value of 4. Well, 4 is still greater than 2, we'd do this again. It'd pop up 4. Well, then height would be equal to 3. 3 is still greater than 2, so we do it again. And I can run this, and we can actually see what this will look like. I think it's still open in the browser. Yeah, so if I refresh this, oh, whoops, I forgot to take out the HTML from the JavaScript. Take that out, refresh. My error's gone. Notice how fast I saw that because my developer tools are open. Enter the height, I'll say 5, and enter the radius is 2. Get volume. Here's my alert box. Okay, we popped up 5, and then 4, and then 3, and then it finished. Okay, and it finished because once I said, okay, 3 minus 1 is 2, height is no longer greater than radius. Height would be equal to radius, and then we'd be done. And so our computer is capable of performing the same piece of code practically infinite times. Okay, let's go to our next one. Function call and return, we already looked at that one. All right, it's this guy right here. I made a separate function. Notice that my volume right here still showed up right here. Exactly the same as it did before. I have the separate function here, but instead of computing the volume right here, I actually call a function to compute the volume. and then I returned that value, assigned it to volume, and then we outputted that volume to this output div to display it right here. Okay, but that also changed my control structure. It changed that default just running top to bottom. Instead, it's like, oh, all of a sudden I'm going to go from line 35 to line 23. And then from line 24 back to line 35 to assign a value to volume. Okay, let's see what other control structures we have. Try, catch, throw. We're not going to go into those at all this semester, but I want you to know that they exist. And it's just for error checking. It's really similar to this one right here, this selection, where it checks a condition, and if that condition is met, then it will do something. These try, catch, throw errors, maybe the try is prompt the user for a number. And if the user doesn't type a number, then we'll catch that error, and we can either throw an error or tell them to try to type in a number again because they failed. But it's basically to catch errors, so that our programs can be more robust. Any questions about these control structures? Okay, sweet. Well, let's keep going then. Oh, that was all I had. Okay, well, sweet. So I know that this right here looks very, very, very foreign to the majority of you, and that's okay. I'm putting this here just so that you can see what your code is going to look like in just a couple of weeks' time and kind of see where we're going. This right here, we're not even going to touch until week 8. Okay, so you can let go of that. This right here, we're probably not going to touch until like week 10. Okay, but we will start working with JavaScript and working with HTML and calling functions from JavaScript in just 2 weeks. Okay, and this is kind of what things are going to look like. So. All right, and hopefully it helped you guys understand how these control structures work, how they can be modified, and how our programs can run in different ways. So, okay, well, any questions before we call it a day? And it could be about anything. It could be about this stuff. It could be about something and I learned something about next week, last week, the weather outside, anything.
I know I talk a lot, but I guess I'm the only one talking, so they'll have to live with it unless they talk. So JavaScript is much like C++, since that's the other class I took with you, and a lot of this stuff looks similar. Are the main things just the heading? Because that's mainly the things I'm seeing different within the functions.
Yeah, so I mean, comparing to C++, obviously HTML looks completely different.
Yeah, HTML and CSS are like out the way. Those are way different.
Yeah, because they're not programming languages like C++ and like JavaScript is. Other than that, though, you can just expect to see syntax differences.
Syntax.
Notice right here, I'm not saying float height.
Yeah, you're not. Yeah.
So
char.
Yeah, so JavaScript doesn't have types like C++ or Java.
Okay.
Like those languages have. There aren't any types. And so right here, I could declare a variable as like age equals 23. And in C++, that would be an integer. But then I could also say age equals 23. And that wouldn't throw me an error. Okay. And so a lot of people coming from a programming language that's typed, like C++, coming from that kind of a background, they see that and they're like, dude, that's messed up. Okay. But that's
what would it return back when you said print age? Or like if you had it, like would it say 23 or would it spell out 23?
So right here, so I can just put an alert box right here and it'll just have that pop up again. And I can put this variable, and so we'll have 2 alerts. Okay. And we should put semicolons after these, and let's see what happens. I don't think I deleted my compute volume function. So I'm going to break this for a sec. I think it was math.py times radius times height, I think. But let's run this real quick. We don't really care about that. We care about the age. So I'm going to hit F5. I'm going to call the function. Notice my pop-ups didn't happen right now because this code is inside of my function. And this isn't going to run until we call that function, in this case, from the button. So I'm going to hit the button. It says 23. And it says 23.
Okay. That's cool.
Yeah. So great question. But outside of that, Samuel, you'll just see a lot of syntax differences.
Okay.
A lot of them are really similar, like this. Looks pretty much exactly like how you do arithmetic in C++. But a lot of these functions will be very unique to JavaScript. And you'll notice probably quite a bit easier than C++.
Well, this should be fun. Thank you so much. This was a good
Yeah, you're welcome. Okay, well, if there aren't any other questions, I think I'll let you guys go. Okay, Amy, thanks for being here. Thank you all for being here. I hope you guys have a great week, and I'll talk to you guys soon.
Thank you.
Okay, thank you.
Thank you.
Thank you.
Thank you.